So I'm gonna play the game now so that I can just show you guys what has been done so far, and everything was written in C++. And there we go. It's just like Yu-Gi-Oh, but with a touch of XCOM 2 and the Yu-Gi-Oh anime itself. Activate, activate. Yeah. So can battle, does damage 6,900 from 8,000. Can do battle minus 1,200 becomes 5,700. Now I have two battle counts has been used, attack counts. So I don't have any activation count, battle count, draw count, and move counts. They've all been exhausted, so I just need to move on. So it's now the AI's turn. So these are card in deck, card in hand, card in field, and units in field. So you see the numbers change based off of where each items or items are placed. So I think AI is out for revenge. Whoa, it just took out my units. And they're done. I can move this card and I can add a spell, move a spell. I want to activate this card, it spawns this, and a spell. Let me see what it does to Chiron when I activate it. It adds 500 points to its Chiron's attack. So Chiron's attack becomes 1,650, and that spell card is gone. So I can attack with Chiron now. This is too easy. Yeah. And there's no one defending this guy anymore, but I've exhausted my battle count in this turn. So it's AI's turn now. Let me see what it's gonna do. It's activating its spell card, but there's nothing to activate it on. No units. So he has exhausted everything basically. Oh, I have more unit cards. Move. I don't think this AI is going to survive the next wave. Activate. Activate. I'm gonna still use Chiron to attack because he has the most attack power. 4,050. I'm gonna use Chiron again. 2,400. Let's see what AI does next. He didn't draw a card. Okay. Why do I keep getting unit cards? Let me see. This has 1,400 attack Apollo. Let me activate it. So I wanna attack with Apollo. No, I'm still in main state, so I need to move to battle state. Battle. And this is game over. 1,650 minus 1,000 is basically 0. And it's done. I win this round. So the AI is still weak because basically I'm just using basic AI planning. So that's about it for gameplay. So moving on to next. So let's talk about the code. This is like a whole lot, but I think I've arranged it to like a very good standard. I kind of separated each of them and what they do. So I have the ability system, the actors, the AIs, the characters, the game, interactions, library, player, and the UI. So let's start with the main guy, the characters. So there's a character base which extends. Okay, let me just start with the base. The player extends from the character, inherits all character attributes, and the character inherits character based attributes. Let's see units. Unit is inheriting directly from the character base, while AI is inheriting from the character in itself. And I did that because the base is where I put in the attribute sets and the ability system components. So I want all of them to use the same attribute set and ability system component because I didn't want to create multiple. But when I'm initializing this attribute set, I kind of pick out the attribute set for the character type. If it's an AI or a player, it utilizes attribute sets like health, deck count, card count, move count, and the like. While for units, it utilizes just the attack and the defense, basically attack and defense. So most of the unit does not have much functionality because except from battling opponent and battling units, but these functions are basically called from the character player that is initiating that action, either the player or the AI. So we should focus on the. This project is about AI basically, but let me just run through the player first so we can get like a better understanding of what he does. So anything about the player is inherited from the character. So this is where player calls all of its actions. The draw card, play selected card, play selected unit battle, activate selected card, reset counters. You can see you can't find any function like choose a card, choose a unit, etc. because that is being done in the player controller. Unlike for the character AI, are further extended functions like choose card in hand, choose card on field. So these are going to be using like the AI algorithms I'm going to come up with to be able to decide this card in my hand will be the best card to play at this point in time, or this card on field will be the best to activate at this point in time, or to use it or choose a unit on field basically, and etc. Then these are the simulation areas. These are using dummy data. If you go up here, you will see that I have like a game state simulation that simulates decks, hands, card field, unit field. So these are dummies supposed to just simulate to give the AI possible moves and strategies, return policies, action states, and etc. etc. And when I go to the algorithm section, you will see why I did that, though I've not implemented that yet. Currently, this at this stage in point, this uses just the behavior trees and the planned out AI I did, which checks if it's the AI turn, further splits down and checks if it is in main state, if it's in draw state, or if it's in battle state. So depending on the state it is in, it carries out a random action in for that state. So that's what is there at this point in time. Attribute sets. You can see all the attribute sets were implemented here: health, draw points, move points, activate points, battle points. So these are per turn. The points, battle points are per turn. So for every turn, it resets back to the default values. So if during a turn you can also have a card that can boost how many turns and all of that stuff, how many points you can, how many battle counts you can initiate, and etc. etc. So there's Let me talk about the libraries because these are like general functions. So this is an imperfect system game because you literally don't know what your opponent's deck and card is. What is in your opponent's deck or what's in your opponent's hand. You only know what is on field and the cards on field and the units on field basically. So you need to, these are general function that helps you able to get those things and pick from them. So I just created so that I can access it from anywhere in the code. So, and this is for cards, getting deck, getting a deck, getting random card from a data table, getting random card by type, by the unit, getting random unit, getting random spell, etc. And you can get random card for player and you can get all card for a player. But this is usually from the in the code. I didn't initiate all of this. I was just like creating different possible functions that I might need in the process of making this game. And in the AI, for my behavior trees, I created like multiple tasks: select unit, target cell, opponent. These tasks are being called in the behavior tree. If you've used behavior tree before, or you know how it works in Unreal Engine, whereby you have sequences and in those sequences you can call different tasks. So instead of creating a task in blueprints, I created them here, and I don't have to bother about that when creating my AI planning graph in the behavior tree editor. And these algorithms, I created them as components: Alpha-Beta Pruning, Monte Carlo. So I'm going to be utilizing them within the character AI. So when he's making a card selection, I'm going to be calling the Alpha-Beta Pruning function from this component. And when selecting a unit or a target unit, I'm going to be using the Monte Carlo component to call the best unit to use at that point in time in the game, who has like the best reward policy. And I don't think I have anything to talk about in UI because this was not really, these are just extra stuff to further help the player carry out his own task. It has nothing to do with the AI. Player controllers can see I have marked a lot of key inputs to do different things: to pause game, attack, activate, move, which were the buttons you saw earlier. So those buttons, if you don't want to use the buttons, there are numbers binded to each of them. And I think before I roll the prototype out, I'll create like a information UI whereby you can see what numbers activates what of any of these actions. If you don't want to use key binding, the buttons are also provided just for accessibility sake in the UI. So that's about it for the code base. And yeah, so we've looked at the codes and let's take a look at the blueprints. So as you can see, if you've watched the previous video, that's framework 1, and framework 2 is like, it was extended from the C++ codes. So I created like blueprints to implement that in the game world. So we'll be looking at the AI, the behavior tree basically. So I just created like a simple behavior tree for, if you remember what I said when I was explaining the task code, you can see it's checking if it is the AI turn. It checks with the game instance and see if its player 1 turn is true or false, and it proceeds and allows you to go further into the code if it is actually your turn. And it checks your states. If you are in the draw state, it does this, and within this function, anytime you call this function, your draw count reduces by 1, and whenever your draw count reaches 0, it switches your states into the next state. So I did it in a way that you can't just input a random state. It always moves from state to state. It switch states. So then in main state, sorry about that, I think that was an alarm. Uh, in main state, it's basically select card from hand, select a target cell, move selected card to target cell, wait for 5 seconds because an animation will be played here. So um, you don't want it initiating the card while the card is in motion. So I put 5 seconds for that. Then when the card gets to it, you can select a new card from that board, a random card from the board. You can activate that card, then you wait again. Then it checks if it's still in main state, because there are a lot of things that can make you switch to the next state. When you're in main state, it checks how many cards activation count do you have, how many move counts do you have, and if both of these are equal to 0, it automatically just switches your state to the next state, which is the battle state. So when you are in battle state, these are the actions it carries out. It selects a random unit on your board. It checks for a unit on opponent board. If there is none, it leaves it as null. Then you wait 2 seconds and it attack selected target unit. So the attack selected target unit, it checks, is there a selected opponent unit? If there is no selected opponent unit, it attacks the player itself. So it attacks the player's health with the unit attack that was with this selected unit on your own board. If you don't have any unit on your own board, it basically just moves the state ahead to main state and switches the turn back and gives turn backs to the player. So that's the simple AI I did for this simple behavior tree I did for this um, prototype. And the card, okay, my actors. This is, if you remember when I said when the card moves, I always keep like a delay of 5 seconds before it starts. So this is like a blueprint implementable event I wrote in C++ to extend it here. So I used timeline to move this selected card, which is this, to the location, the desired location. So most of the time, this desired location is either like a cell location point, and if you look at the if you go back to the game when I was playing it, you'll see that there are some like arrow pointers. So those are the arrow pointers location it is utilizing to move the cards to. So I think that's about it on blueprints. And there's a lot of UI here, which HUDs and the widgets. This is the overlay. These are cards. These are message boxes. These are menus, but most of them I've not actually arranged them. This will be done when I'm actually done with the final implementations, which is making sure the Monte Carlo simulation and Alpha-Beta Pruning works perfectly. So that's about it for the blueprints. So in this part, I'm going to be talking about the inspirations and resources I used. So this is basically like everything I've gathered on this project: write-ups, links, books, journals, etc. So let me start with the games. So this is Yu-Gi-Oh on Steam. This is like the primary source of this. And what I actually did this was Yu-Gi-Oh, unlike the game, even Bakugan Battle Brawlers, we see how the card masters utilize this card when battling out in the anime, whereby they throw the cards on deck and the monster spawns out. It could be a dragon or whatever then that dragon can further be buffed up using like an extra card, a spell card, and the like. But I noticed that in most of this game, they just stick to everything being cards. If you can see, you don't even see the dragon coming out, you don't see them having that battle. So it's like a very straightforward process. So I wanted to like explore how about you combine units and cards in a turn-based game and see how that works out, and also explore algorithms that can make it work and see if it could be something that could be done more. And also for the units section, I kind of like used XCOM's style. If you've played XCOM before, it's a turn-based game whereby you have 5 troops against 5 or more enemy troops, and you have to like pick out and do strategic um, take out strategic actions to defeat the enemies. Basically, it's quite hard, I'm not even gonna lie, but it's a beautiful game. So these were the two algorithms: Monte Carlo Tree Search and Alpha-Beta Pruning. This is Geeks for Geeks implementation of them. Then I was reading about Hanabi Challenge. It's a reinforcement learning paper that also explains how imperfect information systems and AI can how you can use AI and work around imperfect information system, because this our system, you can't see the cards deck, you can't see the opponent's deck, you can't see the opponent's uh, hand. You can just see what's on the field. So how do you make a decision whereby, unlike in chess and go where you can see the whole board, but here that's not the case. So this was a good read. I picked out a couple of stuff from here for explaining how to use imperfect information. Then there was this Mastering Chess and Shogi by Self-Play with General Reinforcement Learning. You see how different agents were compared, and we see how Monte Carlo Tree Search was used in a perfect information system and its results basically. So I was using like elements of all of this to put together my own documentation on how I'm gonna implement the. Then I watched a couple of GDC talks, especially this one by Chris Cavalli, and he was talking about hybrid approaches whereby you can start with a finished state machine and put your neural networks underneath it. So, which is why I started with the AI planning with behavior trees, because I plan to implement the Monte Carlo and the Alpha-Beta Pruning um, underneath the task selection basically. So either when you are choosing a card or you're choosing a unit, that's when you use the algorithm, not the algorithm now controlling the behavior tree basically. And there's this book as well, Artificial Intelligence Games by Georgios N. Yanakakis and Julian Togolus. On page 121, you can see how he drew out like a graph that shows you what is best for the game type, how to specify which one is the perfect information, if it is deterministic or non-deterministic, and by turn-based or real time. So it's more like an XYZ plane, and you can see how he separated these games to better place them in their right genre. So this helped me understand what where my game should be categorized in. But I feel like it is in between these two, somewhere around here, because it has a perfect information regarding the board, but regarding the hands and the deck, it's imperfect, because when everything comes on the board, it basically becomes a chessboard You can look at it like a chess checkers kind of game and see different moves and how everything plays out. But outside that, the decks and the hands, it becomes like a battleship where you're trying to figure out, oh, what is the opponent holding in its hand or in his um, in his deck, basically. And it is basically a turn-based game, so it is around here. There's nothing regarding to Halo, Pac-Man, Super Mario, because those are all real time. So these are the games I'm looking at: Scrabble, poker, battleship, checkers, chess, and go. And this is the battleship game. Yeah, that's basically most of the resources I've been looking at, and these are like more. I've been also reading other textbooks and journals, reinforcement learning for games. This could go into my bibliography because I'm not actually using them. We can also explore how we can add Q learning to this game and see how well it can go. I also like broke down reward system policies in imperfect information. Basically, these are like most of my documentation. Okay, let me just, this is putting it all together for imperfect information game. The alpha-beta pruning will help the AI pick the best move by carefully considering and pruning potential moves. MCTS will help AI simulate many potential future gains, factoring in different possible hands the opponent might have. Policy is now more about balancing risk and reward under uncertainty, and reward system will guide the AI towards winning strategies. And the holistic approach allows the AI to be strategic, smartly guessing and simulating different scenarios to make the best possible decisions. So that's all about work. I've written out literature review, but I can't share that yet because it's still in the works, and I'm kind of like writing out my application while I'm trying to implement my Monte Carlo and Alpha-Beta Pruning in to replace the randomization I already have in the game. So that's all, guys. Wish me luck.